So topic 22 is looking at two populations and comparing the means this time. So we're doing test of the means, confidence interval of two means, and comparing the difference between the two. Again, a lot is going to be exactly the same as topic 21 with the proportions. The symbols on be the mu instead of the pi. Make sure you are labeling both, defining both, so everyone knows exactly what each symbol and each variable is that we're talking about. In this video, I want to talk about the dependent samples a little bit. And what I want to talk about is just one of the things you need to be able to do is tell the difference between a match pair dependent sample and the independent samples. The dependent samples are when you have the before-after, pre-post test, and you're comparing. It's one individual, and you're taking a score from that individual at one point, and then you're taking a second score from that individual, and you're comparing the two. And we're seeing the difference and comparing the difference between, which is really what we did last time with the proportions. It's what you are doing with the independent samples. With this one, I want to talk about the formulas a little bit. And what we have, okay, when we're looking at the test statistic, we have T and we have the sample difference. This is symbol here, the little D there is talking about the difference between the two sample averages. And we're comparing it with mu of O, which is the value that's in our null and alternate, divided by standard deviation, divided by the square root of n. And that standard deviation is also the standard deviation of the difference between the two groups. So you're going to have to do some subtraction, which I'm going to show you in the second video, a fast way to do it on the calculator. So you won't have to do every single subtraction problem for you. Depending on how big your sample is, that could take a little bit of time. What we're going to look at here is the null and alternate. We have average of A equals the average of B. Okay, mu of A equals mu of B. I'm just using the alternative not equal to. Now, what I want you to think about, and this is for more of when you're asked questions about how does this affect the p-value, how do you make the p-value smaller, things like that. I want to think at the formula and look at the formula for a little bit. What that mu of O is this time. When we looked at one sample, that value there, we were comparing it to a numerical value saying the average is greater than 75. The average is now greater than 1,000, less than 1,000, or just not equal to 1,000. And that's what value you plugged in there depending on the problem that you had. Whatever value you had in the null and alternate. Well, this time we don't have an actual numerical value that we can see. Now, again, we're going to talk about the algebra for it a little bit. If we were going to bring this mu of B over and you subtract it, another way I showed you of writing this would be the null mu difference. And if these two are equal and you subtract it, it's going to be equal to 0. That's the value that would be plugged in here. So another way to look at this formula, I'm going to turn it this way and write it real quick, would be the average difference minus 0. And you're comparing how far away from 0 you are. If there's not a big difference between the two averages, you're going to have a value very close to 0. So the closer these two values are, the smaller test statistic you're going to have. Smaller test statistics on give you a larger p-value. Okay, larger p-value means you're on fail to reject, and there's no evidence for the little or no evidence for the alternative. Then, okay, the farther these values are from each other, the farther you're going to be from 0 means you're going to have a bigger test statistic. Okay, so let's say if the difference was a very large value, you'd have a very large numerator, a large test statistic, and then a smaller p-value. Okay, so make sure you're thinking about when you're reading the problems. Just because you see two lists, a lot of times once you see and think and practice a little bit with the independence, a lot of people want to jump to that one. Basically, a lot of times because I feel like the problems are a little easier to calculate. But you really have to think, is it a match pair test where you're taking two samples from each other and subtracting them, where each one's going to have a corresponding entry in the other sample? Or is it two completely different groups of people? So really think about match pair versus independent. That's going to be very important when you decide what test you're going to run. The null alternate, that shouldn't be much different. The conditions aren't all that different. A lot of that's going to be the same. But the test that you actually run will be a little different. Okay, so the next video, I'm going to do an example of running the test and show you a shortcut on how to use your calculator to get the list of difference there.